I'm going to be talking, this is perhaps a nice segue from a couple of things that we've already seen this morning. I think one of the lessons that we got from Scott's presentation is that they had created something that they saw as sort of a scripting environment, but people wanted to see visualizations. They wanted more information about developing these scripts. And perhaps that's a common lesson with the Chelsea's Plotly presentation as well. So I want to talk about deep learning and deep integration via Jupyter. But this is really, that's probably the wrong title. What this is really about is, so I've been working with Jupyter for a while, but this is the first time that I've written a library for Jupyter. And I found myself creating this library in a way that was different from what I've created libraries in the past. And so I'm going to give this talk backwards. I'm going to not introduce myself yet. I'm going to introduce myself later on the panel. And I'm going to give the punchline first, so completely backwards. So I'm going to be talking about this project Connects. And if you are a developer, or if you want to look at some deep learning code, you could go ahead and try this. You could go to connects.readthedocs.io, and you could start playing around with that if you want. And this is pip installable package. So I want to start with a, so this is a story about developing software. And I have no confidence. So I'm going to talk a little bit about this project that didn't come out of this deep desire to say, yes, we have the solution. We know exactly what we want to do. We started using a lot of the software in the deep learning world. And I work with some colleagues that I'll introduce in just a few minutes. We're at small liberal arts colleges, and we imagined using the software in our own research and also teaching it to students. And we just weren't really happy with a lot of the deep learning software. And we found ourselves saying things like, I don't like this software. I'm not really sure why, but it just doesn't fit. It's hard to teach. And so we started thinking about creating our own layer on top of this, but we weren't sure. Is this something the world really needs? Maybe students can just adapt to what already exists. So we thought about that for a while, and that led to something that sort of a novel idea for me. And you might know that the standard kinds of metaphors for developing software. There's the old waterfall metaphor where you do it in step by step. First you come up with hard requirements and then design, implementation. But modern, there's the idea of agile software and spiral models. But one thing that's missing from any of these models is the idea of explaining. Nowhere in this design do you actually stop and say, does this make sense to humans? Can humans use it? Is it well designed? Are there consistent metaphors throughout? Do the verbs and nouns make sense in the API, the software that you're creating? And so it's been a while since I created software for students to use. And so we were on this precipice of creating this new machine learning software. We were debating it, discussing it. And we found that by incorporating Jupyter notebooks specifically, early in this process, really affected the way that we designed the software. And what we found was by creating Jupyter notebooks early on in the process and begin to test the software and then try to explain it, cell by cell, we found, ooh, we need to go back to the drawing board and think about the software interface again. And so we found the spiral that really included the Jupyter notebook explanation phase, much more than I've ever done in the past. So we found that Jupyter could really help in the designing of the libraries and the classes and the methods in our software. So that's the big punchline for that. And so I want to go through now and talk about some of the details of creating this library. So, so first of all, it's called deep learning these days. It wasn't called that 5 years ago or 25 years ago when I got my PhD in this topic. And so how many people work in deep learning related areas? Quite a few. You're probably overrepresented, but I think because because Jupyter is just a great tool for exploring machine learning and deep learning. It makes sense that these two communities really like each other. So if you do a search on deep learning, this is why I would be interested in knowing what it is, because how you answer the question, what is deep learning, I think really can affect the way that you teach it. So if you do a search on deep learning and do images related to that search, you'll probably find a lot of pictures that look like this, using various weird color schemes. I'm sure that that far one on the left is not a Plotly theme. And don't encourage you to use inline styling like that. But the basic idea of all of these pictures, and this common conventional wisdom, is that there's artificial intelligence as a big circle, and then machine learning as a smaller circle inside artificial intelligence, and then inside machine learning, there's deep learning. And these are the kinds of systems that are artificial neural networks. And so a lot of people, perhaps most of the people, break up the world this way. But I don't live in this world. I come from a slightly different background. So I was more interested in seeing deep learning connected to other areas besides AI and machine learning. So we looked at the way that deep learning libraries are defined, and then the jargon and the terminology that they're used, they use in order to create the libraries. And it really is an alien language for a lot of other camps. So I guess the Venn diagram that I would draw would not be AI and machine learning and deep learning, but it would look perhaps something more like this. And these are very different kinds of people that are studying and interested in deep learning. And you can imagine perhaps lots of other camps that are interested in deep learning and could actually take advantage of deep learning ideas. In fact, there's some other bubbles. This is a little bit hard to represent in 2 dimensions, but you can imagine this is really a picture of many different dimensions, and these areas and many more bubbles can come in, and maybe you don't come from one of these bubbles, but you can imagine your world could interface with deep learning as well. So we were really interested, and we're at liberal arts colleges, really, we stress the connections between very different kinds of areas. And so, so this is the idea that I had about deep learning. And I didn't necessarily want to buy into the machine learning view of deep learning. We could look at deep learning independent of that. Okay, but what is it? Well, here's one definition that we came up with. Deep learning relates to the design of these networks, and we'll give us a couple of examples, that have lots of stacked layers that through experience, so this is the experience the networks go through, they're able to be trained to produce desired outputs given novel input. So the really cool thing is that you can give it these networks something they've never seen before, and they're able to do really interesting things. So, well, what kind of things are those? Well, first of all, a word about these stacked layers. So you could debate whether or not deep learning is actually inspired by neurons. They really, I put this up here to give you a visual representation of a neuron, and then you can imagine having a stacked layer of neurons that looks perhaps mathematically or visually more like this. And this is how we typically visualize neural networks. And they're really just these layers of numbers. And they go through basically just a vector of numbers comes in on the left, and you multiply, 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 and you get some numbers on the output. And really, this is the type of system, a model that could represent anything, any kind of data. So what kind of problems are these being used on? Really very different kinds of problems. So here are two. This one I just saw on my Twitter feed in the last couple of weeks, this one on the right. So I'm doing a project where I'm training a neural network to generate new knitting patterns. Okay, so this is a person that's in a very different camp from, this is not an AI, ML researcher necessarily, but this is the kind of problem that you can apply a neural network to. This is taking a textual description of a knitting pattern and feeding these in, perhaps a lot of them, into a neural network, training the neural network to give you a different output, and then using it to be very generative to create a new knitting pattern. And here is the human. So this is sort of turn the world upside down. The computer is designing the knitting pattern, the human actually creates it. So the human is the 3D printer in this world. And so she's knitting this to see what it actually looks like. And I've heard that this is, new and interesting. So the same kinds of networks can actually do the problem on the left. So you can give it a picture, and it can identify segments in the picture, hat with a wide brim in yellow, and then in red, it can identify in the picture dog. And of course, you don't usually see those two things in the same picture, but the neural network can do that and identify the different segments. Some other ideas that you can use this, some of the more interesting one, is you can give a neural network like this a black and white picture, and it can colorize it. It can give you the colors that are most appropriate based on a lot of different patterns. And another one that is really quite interesting, I think, it invites a lot of questions about how humans think. So here is a neural network that can style transfer. You give it an original photograph and a reference photograph, and it can take the style of the reference photo and apply it to the original photo. And so all of these on the right are outputs of the neural network. And here is another example of that, where you have on the left the original, and then you can imagine the reference photo or reference image for the other three, one by Picasso, Van Gogh, and anybody name that one on the right? Monet. So they've taken pictures from each of these artists and combined it with the subject, Mona Lisa, and then the network can output this. So this is really fascinating, and we should really try to get these tools into people in the other camps to see what they can do with these ideas. So that's the basic premise of the project. One more example. Have you heard of AlphaZero? So this is really exciting and scary. So AlphaZero is the best game player in the world. What game? All games. So I'm very doubtful that humans will ever be these kinds of games. They're not in the running anymore, sorry. If you're staking your future on winning games in this framework, no, you're out of luck. Computers now rule the world in playing games. And so this is really exciting because these systems don't require humans to train them. They self-train. And they also can get much better than we ever were. So this is an exciting possible entity to explore novel solutions with, to see what are possibilities that we have never thought about before. So So that's the framework that we want to talk about. And so our general goal became, how can we introduce these ideas into the classroom? But do we really want to reinvent the wheel? And so we looked at a lot of different systems, and we decided on a basic philosophy. We shouldn't have students necessarily be wrestling with optimizations or esoteric representations, or having to learn completely different packages in order to do some basic visualizations. What we want to do really is, Python is a beautiful language, and we wanted to exploit as much of Python as we could. So using just regular Python for most of what students do. So interestingly, I'm going to tell you more about this when we talk on the education panel, but I've worked with other scientists, physicists, biologists, and I found myself doing something very different. So normally I teach computer science, and in computer science, I would say maybe we teach first principles. So if you have, well, let me show you an example. So on one hand, there's first principles, and on the other hand, there's a library that encapsulate that. And so here's an example. You have some data there in the middle, and I found a lot of the non-CS instructors that I worked with like to do things on the left. You want to learn NumPy because that's a very useful package. It has a lot of things in it for you, and it does it very efficiently, perhaps the most efficient way possible. And on the right, there's the way that a computer scientist might like to teach the same kind of information. And so this is a lot more verbose, but you can actually see the loop inside of the loop, and that's really what computer science is oftentimes trying to teach. Whereas the one on the left, they give the same answer to a few decimal places. But the non-computer science instructors really like to focus on the left, even in biology and physics. So I found that to be interesting, and I co-taught that course, and I found myself wanting to teach that way to the biologists, and this way more to the computer scientist. Why? Why is that? Well, I think one answer to that is that the biologists and the physicists are working in a different world, and they're trying to get work done, and so learning the libraries and the interfaces and the parameters is really a productive step for them. And so they don't work in Python perhaps as much as they work with libraries. So that was instructive to us in thinking about this library that we wanted to create for deep learning, but we decided to, as much as we can, just rely on basic Python, but then when we have to create these library functions. So these are my colleagues, both at small liberal arts colleges, Lisa Meaden at Swarthmore, Jim Marshall at Sarah Lawrence, and myself at Bryn Mawr College. And so we came together and we decided, all right, we're going to do this. We're going to create this, this library. How much time do I have here?
10 minutes.
Okay. So to make a longer story shorter, we did create some common functionality. We had to replicate a little bit of matplotlib and NumPy, but we did this very carefully and did it very minimally. So we didn't recreate the entire libraries. We very carefully thought about the interface and what is the bare minimum of plotting and numeric utilities they need. And so we sort of think of ourselves as an on-ramp to other topics, including matplotlib and NumPy and machine learning and AI. But we did it in a way that's very independent. So we created this package called Connects, and the idea is that it's easy for humans. And so whenever we needed to make a choice, and perhaps we use a little bit more space or takes a little bit more time, but it made it easier for humans, we made that choice. We made that trade-off. Humans a little bit more than other things that made it a little bit harder to use. So we use lists of numbers rather than something from NumPy. We were really interested in creating tools to let students tell stories, to allow them to take the information that they're learning from the deep learning package and combine it with knitting instructions or something that has never been done before, and give them the tools so that they could create, say, a movie or some other visualization that helps tell this story that's really personally theirs. We wanted to follow the Zen of Python. If you don't know what that is, Google Zen of Python. We wanted to make a system that was free of machine learning jargon. And so I think we might have a little bit of discussion about that on the education panel. I think you could probably take 3 or 10 or 15 different educators and you would come up with 3 or 10 or 15 different opinions on what the right thing to do is. So do you want to create an idiosyncratic library that's very different? Or do you want to make it a standard to fit into a bigger puzzle piece of all the different libraries and using scikit-learn and a lot of other things? Well, it depends, I think, on your motivations, who you want to address, the students that you see that you will work with. We do use the word dashboard in a slightly different way. So we have a little neural network dashboard, and I think we might have time to take a look at it. This is, if you know machine learning tools, this is a layer on top of Keras, which is on top of TensorFlow and other backends. And we really wanted to make it work nicely with Jupyter. This is just the one slide that goes into the details of the library, but so it created this picture on the right automatically. It's SVG based. We found that SVG images, which are often just lines typically, can contain images themselves. So what we did was to try to cut down on the bandwidth needs of creating lots of visualizations like this when you're on a Jupyter Hub system, is that each one of these pictures can be replaced independently by a little bit of JavaScript. And so you can have a display in the notebook, and then each of those pictures can be independently updated. Let me just show you an example real quick here, and I think maybe we'll stop and leave some questions. So this is one line of code to take a neural network that's been trained, and so the student this is 2 different data sets, the inner ones and the outer ones, and the neural network has to learn to separate those. So we wanted to be able to create these kinds of tools, and I think it's the same kind of metaphor with Plotly. You want to be able to create these nice visualizations of understanding what the network is doing, and so it helps the students, but it also helps the students tell stories about what they've done. All right, so just a reminder that the punchline, one of the punchlines was we incorporated Jupyter early in the design process to make sure that we got explanation teaching in that loop, and that really did affect the library outcome. And I think I will stop right there for questions.